Okay, thanks, Joe. We've had a little technological program, so we've reverted to the old style where I'm going to say next for each slide. So, launching into it, our team at Dock and Nelson have had a field program going between 2010 and 2016, investigating the impacts of 1080 use on a range of forest birds. The write-up for this program is sort of getting close-ish. We're not quite there. And so I'm going to outline the program and describe one piece of the work in detail. That's our work on carcass. So next, please. Okay, the work was carried out at 3 places: in the Tararuas near Wellington, in Tennyson Inlet in the Marlborough Sounds, and near Lake Paringa in South Westland. Next. We're going to get sicker next. Hey, so we monitored a range of species, including Titipanami rifleman. Next. Kaka. Next. Robins. Next, moorporks, wekas, and we also did bird counts with digital audio recorders to monitor the changes in a whole pile of species. Next, please. Okay, so the work on wekas and robins is already written up and finished. The work on Titipanamu and carcass, click another button, please, Tiffany. It's sort of 3/4 done. We're submitting papers, and I'm going to talk about the carca work. And the Ruru work and the bird count work hasn't been done. So sort of preliminary results on the wekas is the wekas did really, really well because we killed the stoats, and robins kind of did what Susan predicted. They did really, really well initially, but then we had a bounce back in rats, and the net effect was not so flash. Anyway, I'm going to talk about 1080 and carca. So this is the effect of 1080 on carca: nesting, success, and survival. And it was work that was kind of led by Jason and I, and then we had help from a whole team of people who did lots and lots of work climbing trees and chasing carcass. So the work was done in South Westland. So this picture's, next please, Tiffany. This picture's kind of got nothing to do with our study, but it's just a beautiful picture of Jackson's Bay in South Westland, mountaintops to the sea with forest and wetlands. Isn't it great? Next, please. Our study area was this 35,000 hectare block centred around Lake Paringa. It was divided into 3 blocks. You can see the black lines on that map. Next, please. So this is sort of the major rivers in the area: the Paringa, the Moiraki, and the Haast. And our study area is about 20 km north of Haast Township. Next. Maybe I'll just say click instead of next. So we had 3 blocks. This Whakapohai block, click. And then Abbey Rock. So these 2 blocks were treated with 1080, and then a non-treatment block to the north. Click. Now, even though we chose these study areas because they were had treatment, they had 1080 treatment in them, but unfortunately they weren't very well matched. So you can see the southern block is mostly beech forest, and the 2 northern blocks are mixtures of beech and rimu. So I couldn't do much about this, so it's just kind of a bugger thing. Next. As well as monitoring carca and 1080 operations, we had a bunch of tracking tunnels for monitoring rodents and mustelids. So we had 48 lines of 10 tunnels, which we ran 4 times a year. Next. And we had wax tags, which we ran for possums. So actually, we did the wax tags for other reasons other than just monitoring our study. So they're all in strange clusters. But we ran some of the wax tags in 7 surveys during our study. Next, please. We also had, we monitored rimu fruiting by counting the amount of rimu fruit on 10 trees, 11 trees, female rimu trees. So we climbed these trees once a year, and we were able to count the amount of fruit that's just about to fall. So we did that annually. Next, please. And then we also monitored silver beech seed fall in traditional old seed fall trays. Now, there's a funny little circle of black dots there. That's not because I placed the seed fall trays in a beautiful round circle. It's because they were all very close together, and that was the only way I could figure out getting them all on the map. So ignore the little round circle. Next, please. So we're going to have to click after each sentence. So kaka are hard to catch and monitor. They don't breed every year. They breed when there's lots of fruit. We monitored kaka nesting success only in years when we thought the rimu trees and the beech trees were going to flower, and that was suggesting the kaka would fruit. Kaka would nest. So we didn't monitor them every year. So each likely breeding year, we attempted to catch and radio tag female kaka in the spring, and then we monitored their subsequent nesting attempts. And we also used these radio tag birds to monitor survival. Next, please. So how to catch a kaka. So you carve a hole in the forest and you stick a mist net up. So here's a hole we've carved in the forest and a mist net going up. Next. The mist nets have got to be really, really high to catch kaka because they're perfectly happy to fly over the top of your mist net. So this is all a bit distorted really, but anyway, so the mist nets go right up to the treetops. Next. And then you play tapes, and with a bit of luck, you attract kaka into the nets, and then you grab them, and the main thing is to secure the bill because they'll have your arm off at the elbow, and then stick a radio transmitter on. We stuck the radio tags mostly on the female birds, and then we followed them around to find their nests. Next. When you find a nest by seeing a kaka going in out of a radio tag kaka going in out of a hole, climb it up. And next, we stuck a camera on it. So most of our nest monitoring was done with trail cams stuck on the trees. Next one, Tiffany. So this is, well, you all know what trail cams are like. Actually, this is on a robin nest, not a kaka nest, but this is what they're like. So next, please. Okay, so here's this kind of potted history of what we got during our study. So we started in 2010, and the year before that, there'd been a 1080 op. So these red blobs are when there was a 1080 op. So in 2009, there was a 1080 block in the middle block of our study area. Next, please. In 2010, there was a 1080 operation to this in our southern block, and there was high beech seeding and high rimu seeding that year, and we found a monster 10 kaka nests. We were sort of beginners at this stage, so I'm sure there was a hell of a lot of kaka nesting activity going on, but we only found 10 of the nests. Next, please. And the next year, the beech seed was very low, and there was a tiny amount of rimu, but we didn't find any kaka nests. They probably didn't breed much. Next. 2012, the beech seed was low and the rimu seed was low, but nonetheless, we still found 8 kaka nests. So it sort of shows that the nest is not entirely tied to the fruiting of those trees. Next, please. In 2013, yet another 1080 operation in the southern block. The beech seeding was high and there was a bit of rimu seed, but not a hell of a lot, but the kaka nested quite well and we had 15 nests. And in the next year, 2014, we had another 1080 operation. The beech was low, the rimu was low, and we didn't find any kaka nests at all. And in the next year, 2015, which was last year, we looked for kaka nests. The beech seeding was high, as was the rimu seeding, and we got a pile of nests, 27 kaka nests they were able to monitor. So that's kind of the potted history of what our study comprised. Next, please. So most kaka nests, as you've seen, nest when the rimu and or beech fruit seed heavily, but there are some kaka nests even when there's very little beech seed or rimu fruit. And we sort of came up with this story that went like, even in the years when the rimu and beech don't produce seed, or don't mast rather, when most of them are, there is the odd tree around that's still producing seed. And then, so if a kaka happens to have a seeding tree in its home range, well then that kaka will nest, whereas most others won't. So you get a little bit of kaka nesting almost every year, and then a lot of it in some years. And then of course, in the next click, Tiffany, there are other sources of food that kaka might be using other than rimu and beech. Next, please. So we found, you might as well click all these, Tiffany. We found 60 nests, 38 were successful and 22 failed. 2 of them failed from natural causes, the trees fell down. 1 was human induced, we caused its failure. Another one failed for unknown reason. And then we had 18 nests that failed due to predators, 15 were caused by stoats, 2 by possums, and 1 by a kea. So we saw all this on the camera. So the kea got in and chomped up the egg of the kaka. Next, please. We modelled and estimated nest survival using GLMs, using techniques very similar to the nest survival package in Program Arc, which some of you might know. And we used this modelling approach to examine the relationships between nest survival and these features. So that's time since the 1080 operation, that's stoat and possum indices, forest type altitude, nest height above the ground. We figured that high nest might be safer than low nest, and distance to the edge of the treatment block. Next, please. So one of the important findings was that even though predators, mostly stoats, are the main cause of kaka nest failure, we saw that from our cameras, the 1080 treatment is a better predictor of nest success than stoat abundance was in our modelling exercise. So we figured that 1080 kills stoats and improves kaka nesting success, but our measure of stoat abundance isn't very good. And we kind of knew that before we started. Tracking tunnels, these were just one-night surveys of tracking tunnels, aren't very good at picking up stoats, so we didn't have a very good stoat abundance index. Next, please. In order of the effect on kaka nesting success, it went like this. Click them all, Tiffany. So it's the time since 1080 was the most important factor in nesting success. Forest type was nest, altitude was the next most important, then nest height and distance to edge. In fact, time since 1080 was a real biggie. Forest type was really quite important as well. Altitude was all tangled up with forest type, as you can imagine. And the last two probably, I'm not sure if they really had any impact at all, but if they did, it was very small. So it's really about time since 1080 and forest type. They were the important determinants of nesting success. Next, please. So this is kind of how it went. The bar on the left is the nesting success in the year of a 1080 op, nearly 75%, and the next bar is the nesting success in the year after. You can see they're roughly the same. But after that, so 2 years after a 1080 operation, nesting success is very low. And in our non-treatment block, nesting success is also very low. So basically, for a couple of years after a 1080 op, you get high nesting success, and then it all goes back to custard. Next, please. So if you add in forest type into this, you can see that the left-hand cluster of bars is what happens when you're more than 2 years after a 1080 operation. The nesting success is low, and then the right-hand cluster of bars is within 2 years of 1080 op, the nesting success is high. But the big thing is that the nesting success in beech forests is higher than it is in mixed beech and remu forests, and that is higher than it is in remu and hardwood forests. So there's quite an important impact of forest type. Nesting success is best in beech forests. Next, please. We monitored kaka survival kind of as a byproduct of having all those transmitters on. So we looked at 1080 biokills. So we had 42 radio tag kaka monitored through 6 aerial 1080 ops. None of them died. In fact, there's over 100 kaka being monitored through 1080 ops now with radio transmitters, and none have died. So 1080 doesn't really kill kaka. And then we looked at long-term survival. So we had 53 radio tagged female kaka, which we monitored for between 25 and 2,085 days. It's until the transmitters fell off. And so we got some measure of sort of long-term survivorship from those birds. Next, please. Couldn't do any complicated analysis on these because to suppose that a kaka survival had anything to do with the forest type you caught it in is probably a little silly because they move around a lot. So I just compared the kaka survival in our non-treatment block with our treatment block, and you can see that the kaka survival was a bit lower in the non-treatment block than it was in the treatment block. I was quite surprised and pleased to see this result. So I think killing the stoats makes it a bit better for kaka even when they're not nesting. Next, please. There was another little complication and an interesting observation came out of that, is that we only had one adult female was killed while nesting in our southwestern study, whereas other studies, like the one at Nelson Lakes, had more than half of the monitored females were killed while nesting. It's a bit more complicated than that, because this graph represents the survival of female kaka on nests that were found by stoats and possums. So these were the nests at which the stoat or a possum got the chicks or eggs. So in southwestern, only one of these 18 nests was the female killed, but in Nelson Lakes, 13 of the 27 nests that were preyed upon, the female was killed. So there's something funny going on here. It's not just that there's more predators in one place as the other, is that even when a predator finds the nest, in southwestern they didn't kill the female, in Nelson Lakes they did. So why might that be? We've got a couple of possible explanations. One is that the nest sites might be different, or that the predators might be hungrier at one place than the other. In southwestern, most carca nests are in Silver Beach, or in Nelson Lakes they're in Red Beach. And in Red Beach trees, the holes are in the trunks, they're in hollow trunks, and the entrances are invariably above where the bird sits. So a stoat coming into a carca nest can drop onto the back of the carca, and maybe it makes it easier to kill it. Whereas in Silver Beach, most of the nests are sort of roughly level, so the entrance is roughly level with the nest contents, and the stoat doesn't get to drop on them. It's just an idea, I don't know whether it's true or not. The other possibility is that in southwestland, it's sort of permanently ratty in the forest we were working in, whereas in Nelson Lakes, it's much more a mass-driven situation with low rats most of the time and high rats occasionally. So it might be that at the time the carca are nesting in Nelson Lakes, there's invariably bugger all rats around and they're very hungry. Anyway, we don't know. So next, please. Okay, so carca nesting success increases in the 18 months following 1080 ops. Carca nesting success is higher in beech forest and remove forest. Carca are rarely if ever killed by 1080. Carca survival is higher in 1080 treated forest than untreated ones. And female carca nesting mortality was low in our study. This is sort of all very well, but it doesn't tell us how often and when we need to use 1080 to protect carca. So we made a simple matrix model using data from this study and from all the other data we could drag from other people's study. And we explored the likely effectiveness of different 1080 regimes and in different forest types. So next, please. So this is what happens if you don't do any 1080 treatment at all. So in my little exercise, I've started off with 1,000 carca on a track of 15 years over time. So they go down. Click. If you did 1080 treatment annually, the population would rise sharply. Not particularly surprising. None of these results are particularly useful because we're not likely to do nothing, nor are we likely to be able to do annual 1080. Next, please. If we were to do 1080 ops when the carca bred, that'd be pretty good results. So the population would still rise steeply. It'd be great. Catch is, it's hard to predict when carca breeds, so it's not a particularly useful solution. Next, please. We could do it when the beech trees seed because we're well able to predict beech tree seeding, and you can see we get an increase in population, carca population, but it's not that flash. And then next, please. We could do the 1080 operations when the rats plague, so that's sort of a year after the beech tree seed. And this is when we normally do 1080 operations during rodent plagues, and you can see from this that it's actually not very effective. Next. The other option we could do is we could do it every 2 years, and because the effective 1080 for carca seems to last a couple of years, that's nearly as good as doing it annually, so that's attractive. Or we could do it in the next one. We could do it every 3 years, and we get about the same result as when we do it during when carca are breeding. So there's a bit of a catch. This data was based on sort of the average of the results we got from southwestland in both beech and podocarp forest. And as I said, things are a bit worse in the podocarp forest in southwestland, and they're also a bit worse at Nelson Lakes where the carcass got killed. So next, please. So these two approaches of doing 1080 when the beech seeds or when rodent plagues are probably not going to work in a lot of the places we've got carca. So the most likely solutions that are practical are going to be doing 1080 on a regular basis every 2 or 3 years. And my final slide. 1080 increases carca nesting success for at least 18 months. 1080 increases adult survival. The existing 1080 regimes, so that's once every beech mast or rodent plague, are likely to cause only slow population increase in southwestland carca. But existing regimes may not cause population increase at all at other places like in podocarp forest or at Nelson Lakes. So we need to carry out 1080 operations once every 2 or 3 years, kind of on a regular clockwork kind of basis. That's what might be required if we want to look after carp populations. And that's me.
Thank you, Graham. That was an excellent talk and really interesting. You've had a few questions already showing how much you've intrigued people with those results. So the first one is from Susan. She says, you're probably going to answer this, Graham, but why does beech forest have higher success? Is it an artifact of the confounding of forest type with treatment?
No, I don't think so. I think that the predator regime is different in the podocarp forest than in the beech forest. So I think it's just to do with the abundance of stoats probably, and maybe possums in those two forest types.
And you've got a question from John. I wonder if you could flick your brain quickly across all the birds you have worked with and summarize which ones do or do not get long-term population level benefit from 1080 ops. That is beyond nesting success.
Well, no, probably couldn't do that quickly just now. And it's that answering that problem is kind of confounded by the results that Susan presented yesterday, which we until recently have been rather unaware of, that for some species we're kind of making rats worse with our existing regimes. But I think that for most of the stoat sensitive species, we get long-term benefits from repeated 1080 use. So that's things like carcas and kiwis and wekas, Theo. For the rat sensitive ones, it's much more complicated. I'm not confident to say which ones benefit and which ones don't.
Thanks, Graham. Question from Matt. Was any genetic analysis done on stoat hairs, etc., remaining in predated nests? Do we know how many stoats are doing the work, i.e. how close to 100% kill must we get to protect stoat vulnerable values, damage thresholds?
No, so I don't know how many stoats were left in our blocks afterwards. I suppose we could say though that whatever stoat kill we achieved with those operations seemed to be good enough for carca if we did the operations frequently enough. That's all. No, we didn't do any genetic analysis to find out which stoats were still around and what proportion we'd killed.
I guess it's difficult as well when your relative abundance estimates for stoats weren't working very well, then you can't really tell how much knockdown you got either.
No, so we sort of have to take that from other studies where it's been done more comprehensively, like the Lane's work in the old days.
So from Jamie McCauley, hi Graham, interested in the lower predation within beech forest, any links between rat tracking and nesting success? What does this mean for a matrix model?
I don't think there were any relationships between rat tracking and nesting success, but I'd have to look at that harder, Jamie. Let's think about it later. I can't answer that off the cuff now.
Question from Elaine. Graham, what happens when aerial 1080 becomes not as effective with repeated operations as happens with acute toxins?
Well, I think the answer is a bit obvious. It's not going to work so well. So to come up with a program like I'm suggesting and doing it every 2 or 3 years, it'd be best if we came up with a program where we were using a range of different toxins or other tools. It doesn't have to be toxins. We can achieve the same results with traps and things as well. But if we came up with a range of tools that we use successively.
Question from Dave Kelly. Will doing 1080 every 2 or 3 years breed rats that don't get killed in 1080 drops, as Josh showed yesterday? Slightly similar question, I guess, in a way.
I think you're probably right. So if the story is that we need to do these pest control operations very regularly, which we all know is true, we know that we've got to increase the number of tools in our toolbox. Basically, we need more than just one toxin to do this.
Thanks, Graham.